spring and summer. That's one of the cool things. About 2 years ago, we started analyzing what we wanted for X-driver architecture, what we wanted for graphics and Intel. I started attending the kernel summit to try to figure out where kernel interfaces were going for graphics, what we wanted to do in terms of integrating the Windows system and the kernel graphics devices in the kernel context. There were a lot of clear directions that we needed to go. Obviously, the architecture that we have today, where user mode manipulates PCI configuration registers, is not sustainable going forward. The architecture we have now, where user mode actually accesses I/O ports directly, is not sustainable. So we needed to do some fairly dramatic changes, and we had some fairly interesting opportunities in terms of architectural changes coming from outside that we wanted to explore. So the question we had 2 years ago is, what do we want? What's going to make us happy? What's going to satisfy the needs of our users, of our developers, and of our even our OS vendors? So what's going to make a Red Hat happy? What's going to make an Ubuntu developer happy? What's going to make Debian happy? Well, I use Debian, so I only care about that. What? Oh, and sorry, and of course.
And Gentoo?
They're just going to turn on new compilation flags and break my driver again.
And Manviva?
Yeah.
Okay, yeah.
Sorry. Yeah, thank you. So the big question is, what's wrong with the current driver architecture? Where are the fundamental problems? What are the limitations of the architecture that we have? What things can't we do that we want to be able to do? And how do we get from where we are today in a relatively clean and incremental process to where we want to be? The important thing here is we don't want to just discard all of our existing code. We don't want to make everybody's operating system break for 3 years while we go off and rewrite the world. We don't have that opportunity. We want to make small refinements in relatively limited areas so that people can both see continuous progress and so that we can, of course, detect problems going forward. So we don't just dump a giant new architecture on the ground, notice that it's completely broken, and take 3 years to figure out how we can fix it. Okay, so what do we want on the desktop? Well, the number one thing we want is we want to make it so that you can have that bling experience that we're all used to now with Codfish. You want to be able to have a composited desktop where all the objects in your environment can be manipulated by a compositing manager and put up onto the screen. Now, that compositing manager is purely a 3D abstraction using 2D applications as paint, or that has some kind of integrated geometry mechanism where you can have SVG objects embedded in your compositing manager. I don't know, but I know what I want. I want to make it clean, I want to make it tear-free, and I want to make it so that you don't get any partial updates on the screen. When people talk about Mac OS X and how clean and fast it looks, the actual performance of the Mac OS X desktop is dramatically lower than Windows or Linux. It looks better because it doesn't tear. There are no partial updates. And we can get there. We've seen it in a lot of demos, but we haven't seen it for the entire Linux desktop. So we want to clean that up. We want to take all of our disparate APIs right now and integrate them together in terms of their ability to manipulate the same objects. Right now, when you paint something with a 3D API, with a GL API, you can't touch those pixels with 2D reliably. We have some extensions now that let you kind of grope them through with rubber gloves on. But it isn't integrated, it isn't clean, it isn't high performance. We want to get to the point where when you boot your computer, you see that boot dialog with pretty flowers on it, and it goes all the way through the OS initialization to the point where you're logging in and you have never seen another screen flash. Your screen flashed when you powered on the computer, and after that you're in graphics mode, and you come all the way up to the UI and log in, and it never flashes again. We want to be able to control the user's experience all the way from power on to desktop. We want to be able to have multiple users share the same computer. Any desktop environment today is by definition a shared desktop, right? Because desktop computers aren't personal computers anymore. There's something you have in a library, there's something you have in your office, in your home, there's something you have in a kiosk in a mall or something. We want to get to the point where you can actually have multiple contexts in that and smoothly switch between them and give everybody the same accelerated experience. Right now, you have one user that logs in, they get accelerated 3D. The next user comes in and uses that computer at the same time, not so much. It's just not a good experience. Obviously, we want to be able to plug things in dynamically. We want to be able to plug in USB video cards. We want to be able to plug in monitors. We want to be able to plug in mice. We want to be able to plug in tablets. And especially in a mobile laptop environment, your experience and your user interface is very dynamic. You go on the airplane, you have no devices. Your Bluetooth mouse is disabled. You come into a conference room, you have a projector, and you have a tablet, and you have a mouse or something. So you want to be able to dynamically change your environment. A lot of the focus that we have these days is on reducing power consumption, not only to increase your, not only to save power to reduce your carbon footprint of your laptop, but also just to make the batteries last longer on the airplane. We all, you know, this battery here lasts about 9.5 hours, and yet that's not enough to get me to Australia yet. So, and I want to go to Australia again. So, and of course, anybody today satisfied that their computer is fast enough? No? Oh, somebody is. Is your computer fast enough? A lot faster than. Is it fast enough?
It will never be fast enough.
There, that's the correct answer. Thank you. So we're trying to improve performance. And another big part of our effort here is to reduce the amount of code running as a privileged user. Right now, your entire X server runs as root. I don't know about you, but that's a whole lot of code running with a lot of privilege. And especially something that talks so closely with the user, with a fairly wide API, the entire X API and the entire GLX API, that's an awful lot of code to run as a privileged user, especially in a process that has your entire memory system mapped into it. It's not even hard to break things with the X server. Okay, so where are we now? We have a composited desktop, right? Everybody's seen Compiz. 2D works great. Textured video, that works pretty good too. Overlay video, not so much. So if you have a machine that has, if you want to take advantage of the video overlay, you can't paint the video overlay onto the side of your 3D cube. It's very sad. The other problem today is that 3D is not composite. If you run a direct rendering application, it punches a hole right through the middle of your screen and paints itself wherever it thinks it needs to go.
With AFLX.
What?
With AFLX.
Yes, yes. I said direct render. No, direct rendered applications do this. No, here you can actually see the window, the gears window. It's over here on the side of the cube. Yeah, and then you can see where the direct rendering application actually paints the window. It paints it where it thinks it should be, right into the frame buffer. Not so good. Yeah, now we know how to fix this. This is not months away. This is weeks away. But it's not working today. Right now, if you want to synchronize your application with the vertical retrace interval, the only way you can do that is to write a direct rendered or a 3D application. The only API that we have that synchronizes 3D. So your 2D applications, they just get to tear. We want to get to the point where all of our applications can synchronize to the V-blank interval if necessary. In a composited environment, there's only one application that needs to sync, right? That's the compositing manager. But in an uncomposited environment or a full-screen environment, your 2D applications may want to sync as well, especially your textured video. Right now, I've got probably a dozen bug reports on the Intel driver for 965, which only uses textured video, that people don't like the fact that video tears. You get a line to the middle of your video in fast-moving scenes. Not pretty, not acceptable. Why is that? I can't sync the vertical retrace interval to the painting of that textured video on the screen. API integration. This is where I have these three different APIs. I have a video API, XV. I have a 2D API called Render. I have a 3D API called GL. They all talk about different objects. The video can't draw to pixmap. So if you try to have a video application painting into a pixmap so that your application can take that pixmap and paint it somewhere else, that doesn't work today. Now the cool thing is that textured video can be redirected to something that looks a lot like a pixmap, but not actually the pixmaps. Video still sometimes uses overlays, so we've got a lot of backfilling to do in drivers so that the video can paint to windows and pixmaps as actual pixels instead of using overlays sometimes. 3D can't talk about 2D pixmaps at all, right? You get a 2D pixmap. You want to do some 3D rendering. Well, sorry, you can't do that today. 2D, the 2D engine, the X-Render API, doesn't know about geotextures. So if you want to take a 2D application and render its output so that a 3D application can paint from it, right now you paint that 2D application in PixMap, and then you call the texture from PixMap function, which literally sucks the pixels out of the PixMap and blows them into a texture with the CPU over the PCI bus at about 4 pixels per second. Like, they're both in the frame buffer. How hard is this? Okay, the other thing we want to get to is where we have no more flash at boot time. No more blinking of the screen, no more tearing of the vertical retraces. You see the vertical retrace bars in the middle of your monitor, whatever.
Get rid of the BIOS of that.
This is fixable. So we obviously in an x86 PC environment, you're still going to get the BIOS coming up in text mode for most of those, right? Not much you can do about that. But as soon as I get to the boot screen, I want to get to graphics mode and move from there all the way through the boot process without flashing again. And do as good as we can. In an embedded environment, we can do better than that. Yeah?
Will we still have the option to use small font or high resolution for the text controls?
The question was, are we going to be able to configure what fonts we have on that screen? I don't know.
I'd really like to have my 32 lines and...
You want a fancy console. So the man wants a fancy console. I have a really fancy console for you. It's called Console with a K. What? Yeah. So, yes, the question is, when we move to an FB-based environment, will you still be able to have all kinds of fancy console options? We have some thoughts about perhaps creating a user mode console that ran on top of the raw frame buffer that didn't use X. Maybe somebody will do that. Not interesting to me. Obviously, we have a console built into the kernel that runs on the FB interface already, so we'll be able to continue to expose that. And of course, if you want to be in text mode, have a party. You're still going to get flashing. But yeah, not my problem. Okay, so how many flickers do we have today? We get the hardware logo screen, then we get grub, we get a bunch of kernel messages, and we get the kernel resetting the font. Anybody enjoy that? It's like, whoa, what happened? Then the screen goes off, then the backlight goes off, and then it flashes to a solid color, oftentimes the root weave, which is one of our favorite patterns. And then it flashes to the GDM logic. So all these times you're getting screen flashing, the backlight's going on and off, pixels are flying all over the screen. Users are going like, what's happening? My computer's exploding. Okay, we want to get fast user switching, right? Right now you can do VT switching. Ooh, VT switching. Let's see if this even works. Oh, that was fun. Oh, look, it's not on there anymore. Then I can try to switch back and we hope it comes back. Right?
You're lucky.
What?
You are lucky that it works.
Yeah, well, you know, I'm pretty predictably lucky these days. The main problem we have with VT switching, it's functional for 2D applications. So if it was only a fact that it was ugly, it would be somewhat tolerable. The problem right now is the DRM is limited to 1 VT. So you only get 3D acceleration on 1 VT. If I want to move my 2D driver to relying on DRM for all of its acceleration, that's going to be painful if I can only have one user using any acceleration. So we need to fix that, obviously. Hot plug everywhere. Finally, we have video output switching working in most drivers. All the open source drivers now have Grindr 1.2 niceness. We have a problem right now. We can't resize the frame buffer. Which is to say, when you plug in your external monitor and you want to have twin view mode or extended desktop mode or whatever you want to call it today, if you haven't pre-configured your X server before you started it to manage extra wideness, it doesn't work. It's like, that's not acceptable. We want to get rid of the need to pre-configure anything. So we need to be able to take the amount of memory used to display images on the screen and change that dynamically. Right now, we have a problem that we can only draw to 1 frame buffer per GPU. That means each graphics card in your machine can only draw to a single frame buffer. The limitation there is that if that GPU has a limited width that it can draw to, the 915 and 945 chips can only draw to objects that are 2048 pixels wide or narrower. So if you want to have two 1280 by 1024 monitors, not an unreasonable expectation, even for people on a modest budget, you can't, because that's 2,560 pixels wide. They're separate monitors. We should be able to create multiple frame buffers. We want to reduce our power consumption. A lot of the power consumption right now is actually caused by the fact that the CPU is never idle when you're drawing. You send a bunch of commands out of the GPU with the 2D engine, and you want to send a bunch more commands down, but the GPU is now busy. It's like, well, GPU, tell me when you're idle and wake me up. Oh, no. Are you busy? Are you busy? Are you busy? It spins. So if you actually do some X11 perf measurements with, filling solid rectangles, which is really boring for the X server, it says, fill. One moment, please. Fill. Right now, the CPU is melting, painting those. Not a big deal most of the time, but if we can get the CPU idle a lot more, we can save a huge amount of power. So we're going to try to do that. We also want to use techniques like gallium, which is going to increase the amount of code and the efficiency of the code running in the GPU by using better compiler technology. That will take our shaders and make them run faster, which makes them run with lower power. We want to make things obviously faster. Right now, for most GPUs, the render extension is not accelerated well enough. For 965 and 915, it actually has credible acceleration for all the basic compositing stuff. But all the other stuff, trapezoid filling and text painting, all that kind of stuff is pretty bad. So some architectural commonality between the 3D and 2D side would be really nice. I don't know where that is. I've been looking at Gallium to see if that's going to make a nice integrated 2D, 3D API. Not as far as I can tell yet, but things can change. 2D really is different than 3D in some pretty fundamental ways. X has some pretty serious security issues. The entire X server runs as root. The X server maps every I/O port in your machine right into its address space. So if you make a mistake, you could reformat your hard disk. Yeah. The X server maps the entire graphics card. So if the X server crashes and has misprogrammed the video card, you power cycle. That was a good plan. One recent good change is that it no longer reconfigures the PCI devices in your machine when it starts up. That's kind of a nice change. It used to actually make sure there was space, so if your BIOS misconfigured your video card and didn't know how much memory it had, your BIOS might stick your PCI controller right on top of your video card where there was memory that the video card wanted to use. So when the X server started, it might say, oh, that PCI card running your disk needs to move. We'll just remap that so that the X server has enough space. Hope it all works out.
That never happened. No, never happened.
Yeah.
It never happened. It never touched anything but graphics. You can see from it.
Yeah.
It never touched any.
But I think things can happen anyway.
That never happened.
Yeah.
Do you have a system where it happened?
It can try. It's not supposed to. Well, the code is there.
When they didn't move the graphics chip.
Yes. Okay, so in any case, how are we going to get to where we're going? Obviously, for composite and 3D applications, this is not hard. This is the place everybody wants to be. Right now, every 3D application shares a common back buffer that's the size of the screen. And that's why they have to know how to clip to that. They actually have to, so the back buffer is clipped exactly the same as the front buffer. So all your 3D applications actually render the scene multiple times to each clip rectangle on the screen. Draw a curved window over your 3D application, and it's going to do multi-pass on every rectangle on the screen, hundreds of them. Move that curved window around, and it has to update the recs to the 3D application, to the direct rendered application, so that it can paint them correctly. It's really icky. Obviously, what we want to do is move to per window depth and back buffers. And then we want to be able to take those private back buffers and swap them to the redirected window buffer instead of the frame buffer. So there's going to take some changes there. We already have a demo of this working, so this is functionality that's actually landing fairly soon. Yay! Finally. Synchronizing to retrace the 2D applications right now, the easiest solution to get to tear-free video is to actually make it so that the 2D applications can tell the compositing manager when they've finished a frame. So the compositing manager can then use the 3D API to synchronize with the vertical retrace. Obviously, we want to make it so that full-screen applications, especially video players, can sync to vertical retrace without having to be redirected. It's a pretty good performance improvement. So we want to make sure that XV, the video API, can use DRM for buffer swaps. Can use the DRM blocking mechanisms for swapping buffers. AIGLX again needs to be able to block in DRM for buffer swaps. There isn't a lot of action going on in this part of the API. It would be nice to see somebody actually take a stab at doing this. We're integrating our drawing APIs. As I said, we had 3 APIs, video, 2D, and 3D. It's fairly simple to integrate video. The code is already there. We're doing textured video on lots of hardware. And in fact, the only thing breaking XV from being able to paint the pix maps is if the drawables of pixmap return fail in the XV code right now. It's like, well, why are those 2 lines of code there? So it's impossible to write a driver in the Xorg server that can do XV to pixmaps today because the X server has failure for pixmaps. So I think we can fix that one pretty easily. I've tried. 3D GLX. Now, as soon as we get to common objects in the graphics card, where we're using TTM for all of our graphics memory management, and we have objects that we can name, all of a sudden those object names can be moved between the 3D and 2D world. So I can take an object from the 2D world, use that object name, and hand it to the 3D system and say, hey, here's a new texture for you. And one hopes that the 3D engine will be able to take that object and use it as a texture. There are some graphics cards that is going to make this pretty difficult. I know in Intel it's going to be easy, but I live in kind of a privileged world because my graphics card is so simple. Yeah. It's nice. Yeah. UMA. It's a slow world, but it's simple. We already have demonstrated the use of this new memory management, TTM, for 2D drawing and sitting on a branch. So we're creating objects for pixmaps, we're rendering to them. There are some performance issues. It's really slow. But we think we can fix them. Let's see, flicker-free boot. This is being handled by putting all of the mode setting into the kernel. Jerome talked about doing this in the Radeon driver. Fairly simple. You take the mode setting code that's sitting in the X server and you put it in kernel mode, and then you create an API between the kernel and user space that exports that functionality. One of the interesting things about the Render 1.2 development was that API became really clear when we figured out what the commonalities were between existing graphics cards, and how they did mode setting, and how they did, the layers of output manipulation we needed to do. So we finally had a common language to talk about video card configuration, and that language has now become this proposed kernel interface. It's very similar to the Render 1.2 protocol, where we're talking about GPUs, CRTCs, and outputs, and you just plug them together. And there's limitations on what plugging can happen, and then you have some additional bag of properties if you have additional mode characteristics. For video, you want to know what video format you're using. Is it PAL? Is it NTSC? Is it CCAM? What video mode you have. If it's an LVDS, you want to know whether you're stretching to fill the screen or whether it's centered in the middle of the screen for a non-native mode. Simple stuff like that. And the Render 1.2 stuff really showed us how to get there. The DRM stuff is currently on a branch. Do you have a question?
Have you figured out the interface for EDID quirks?
So the question is, have we figured out the interface for EDID quirks? And I don't think there's a kernel interface that we know of yet to do that. Our plan is Currently, I believe the way the code works today is the EDID quirks are still handled in user space. Note the third bullet here on the slide. We don't really know how to get the kernel to come up in the right mode at startup time. Our plan is to have all that data stuck in the initRD, and the initRD, when it comes up, will configure the frame buffers correctly. So your screen is blank until the user space starts, and it can load a frame buffer configuration utility that reads data out of the initRD and configures an appropriate mode. So you're going to configure it and then save it to the initRD, and the next boot time it'll come up in that mode. So I don't think it's too complicated.
Yeah, we don't know.
Okay, fast user switching. Multiple DRM masters, DRI2 already provides this functionality for us when it gets integrated and we're ready to use it. Obviously, the frame buffer object manipulation from PTM gives us the ability to create multiple frame buffers. Now we just need to be able to have some protocol for saying, oh, use this frame buffer now, or use this frame buffer now. Or let me create a third frame buffer and merge the contents of these two frame buffers together, kind of a super compositing manager user switcher thingy. Yeah, we'll have some demos of that pretty soon, I hope. The code for this part is actually in Fedora right now, and we're doing some experiments with that, and we're expected to ship it upstream fairly soon. So moving to DRI2 is happening fairly rapidly, and that should give us a whole bunch of this functionality. Resizing the frame buffer, this is going to allow us to fix our hot plug monitor problem right now, where you can only hot plug monitors as long as you pre-configured your server to let you hot plug monitors. Yeah, not an ideal situation. We have to throw XAA out the door. XAA has a fixed size frame buffer that you can't change. It doesn't have any provisions for changing the size of the frame buffer. EXA really doesn't care, the new acceleration architecture. There are some 3D drivers, 3D driver issues. Moving to TTM will help resolve those. Right now, there isn't any way for the 3D drivers to know that the frame buffer, the front buffer or back buffer have moved, and so they'll keep drawing to the old back buffer. It's not so good. There's notifications. The 3D drivers don't actually do it though. So there is some code in there to make this work, and I think it worked for a while in 9.15 actually,
Right, yeah.
when they're doing the rotation stuff.
I've certainly seen that work.
Yeah.
So
Yeah.
bang on it, it will work.
Yeah. Yeah.
The mechanism's there anyway.
The mechanism is there. It's not very complicated. It's mostly a matter of moving the 2D driver is clearly the problem right now. And then we need to fix the 3D driver to actually check to see where the frame buffer is.
That's right, because that stop that was turned off because the render
Right.
fixed the particular issue that it's there for.
Right.
But if you're reintroducing this, then
Right. Right. So actually, a coworker of mine says that there are some problems in the DRI interface that make this difficult to do. I don't know. The rotation stuff didn't change the size of the frame buffer, just the location.
I can't see why it'd be an issue.
Yeah, I don't know. This is some work that Adam Jackson is working on, the shatter stuff to use multiple frame buffers. This is similar to, but it's almost entirely different from the old Xinerama code. The old Xinerama code would let you use multiple GPUs to have multiple screens and integrate them into one big screen. That worked at a very high level in the X server and actually duplicated all rendering across all screens and all of your rendering objects across all screens. So if you had a pixmap, it would actually instantiate the pixmap on both GPUs. If you had a window, it would instantiate it on both GPUs. So every time you drew anything to any object in the system, it would draw it on every GPU. We clearly don't want to do that when we have a single GPU. So what Shatter does is moves down a level in the server, and it only muxes out the drawing to the individual pixmaps themselves. It expects the underlying acceleration functions to be the same for multiple pixmaps. So we should be able to get some pretty, we should get no performance penalty and no memory usage penalty with this particular design. And that's going to get us to the ability to use, to have extended desktops that are wider than the maximum rendering size supported by the drawing engine. We have some questions about how this is going to work with DRI. There's a lot of hand-waving going on. Because right now, one of the nice things about private back buffers is that if the windows are not wider than the max, if the individual windows are not too wide, then it will continue to work just fine. But once you want to draw to a single object that's wider than the GPU can handle, you have to do multiple rendering. I had some, it seems like the existing clipless code should make this relatively easy because the 3D code already handles the ability to re-execute the operations for different clips. This is kind of like different clips, but there's a different object that there. So I think it'll be an adventure, but a manageable one. Obviously, we want to reduce power consumption. To get rid of the spinning in the 2D driver, you just move to DRM. DRM can wait. When you use TTM to queue a bunch of requests onto the card, and the card is busy, it blocks, waiting for an interrupt. It's a novel concept. Yeah. We need to extend XVMC right now. The motion conf extensions, the XVideo protocol, they only work with MPEG. And as we know, MPEG is not the be-all and end-all of video formats. We now have 3 or 4 new formats for Blu-ray. China's coming out with a new format. Microsoft has their own format. So we